and it's going to be recorded on this computer. So just for the purposes of the recording, a very warm welcome to everyone who's attending this evening, whether you're a member or a supporter of Christian Engineers and Development, or CED for short. Maybe you have no prior connection with CED, or whether you know more about us. Whatever the case, you're all very welcome. I'm Mike Beresford. I'm one of CED's directors, and this is the second of our CED Tech Talks. The talks came about after we finalised our latest strategic plan. One of our priorities was to focus on knowledge and skills, and there are two aspects of this. Firstly, we want to increase our own level of understanding about development technology, and secondly, we want to share the knowledge we have with others who work in our field of work. And this particular talk, we've invited Stephen Morris, who's not within Christian Engineers. I happen to hear about him through a church that I visit as part of Zambezi Mission, which is my job. And Stephen's father said, oh, you must find out about what he does, and gets involved in building churches. And when I work in Malawi, I see a real problem with deforestation. Firstly, for firewood, for cooking, the most serious one is charcoal, again for cooking, but also burning bricks or firing bricks. They make what they call in Malawi ovenies. So it's an oven that they then put large amounts of firewood and fire the bricks. And it has quite a serious impact. So I'm always really interested to hear about rammed earth. And so we're delighted that Stephen's able to speak to us about it. So I'm going to remove the spotlight from me. I'm going to put it onto Stephen. And I'm also going to make sure that you can share your screen as well. You're very welcome, Stephen. And perhaps you want to introduce yourself and just say a little bit about yourself before you get us cracking.
Okay, well, I'm Steve Morris. My background is agricultural engineering. I was born in Africa and kind of grew up in the Congo. I've worked in Africa and also in India, primarily in practical and sort of rural development work, alongside other sort of ministry work that I've been involved in. So that's kind of my background. I've always had a passion for environmental issues. And as an engineer, I've always found that there's always sort of tensions as well that come with that. And I'm a problem solver just by natural instinct. So I'm always looking to look at maybe a better way, a simpler way, an easier way of trying to achieve the same thing by minimizing design, minimizing materials. But also one of my biggest passions is really for helping people who are struggling. Hence a lot of my work has been in the slum areas and in rural areas. But I've also recognized that even though I can attempt to help an awful lot in those areas, I have found maybe the best way and maybe the most effective way is to combine that with reaching out to professional people and to get them to think or to rethink about maybe the ways that they are currently doing things, particularly as in construction, but also in other areas like water harvesting. We looked at that last month, and also in sanitation and different ways of just improving people's conditions, but not necessarily going for the obvious So that's kind of my background. I picked up one or two names as a result of it. One of them will come up in a minute when I'm reading through some of my work, but it's a reflection of how I approach things. So that's a little bit about myself and my background. So I mean, it's lovely to be able to meet up and to be able to share with all you people from really all around the world. Probably most of you are better qualified than myself in many areas, and also just, you know, the experiences that you got, and it's just going to be, I think I'm going to enjoy listening and being able to share. There, can you hear me now? Okay. So for the purpose of this, we're looking at construction techniques using earth as a medium. In particular, I'm going to be focusing on rammed earth. And there's a resurgence of this technique that's coming about. There's also another technique which I also would get involved in, and that's bagged earth. There's a lot of similarities there, but it can be used for different areas. And in particular, even though rammed earth is good for seismic areas, bagged earth is actually lends itself even better for that. So again, bagged earth is another area which would particularly interest me. So really just going on with this, I mean, earth has really proved to be one of the world's greatest building material for many good reasons. And just to list a few of them, it's very, very durable, very long lasting, universally available. In a sense, doesn't matter where you are, unless you're in the desert. But then again, that's where bagged earth comes into its own as well. You also have, it's a very natural solar collector, retainer, highly resistant to earthquakes. It's readily available to those with land in particular. It's very, very easy to work with, very easy to train people with as well. And I think this is where it has an advantage for many of us, but also has been one of the reasons why it has had a demise, and that it's difficult to monopolize commercially. That's probably one of the biggest areas. I've put together a manual, and it covers all aspects of the training, dealing with the soil, looking at the soil mechanics, looking at location, looking at foundation, then looking at the shuttering system, and going on then to building the walls and the techniques, and then roofing. And I'm going to be working through most of that, or a lot of that today, but we're going to be doing a little bit of hands-on, which would be quite interesting as well, as that's kind of the way I like to teach. One of the, as I explained earlier, I like to keep things very simple, and I often use the KISS approach. Keep it simple, stupid is the normal way of calling it. But in India, the people I've worked with have often rephrased that and said, keep it simple, Steve. So I've kind of picked up this nickname because that is kind of the approach that I have to many, many things. And you will see that in no better way than with the shuttering system, which I have developed and I've used. Rammed earth basically is a man-made sedimentary rock. Rather than being compressed over a long period of time, it is formed and pressed within a matter of minutes. and your walls are built within a matter of days. So it's just sped, the whole process is sped up. It becomes very, very strong and durable. And unlike concrete, which if you were to pour into a shuttering system, rammed earth can be built upon immediately. So when the wall, the section has been rammed down, the shutter comes off, you can actually then mount the shuttering immediately on top of the existing wall that you've just constructed and continue building up. And this is a normal process up to what we would say the ceiling height, so about 8 or 9 feet. And then you would leave it and you would work around to another section. So it's quite quick. One of the big advantages about this as well is that it uses minimal amount of water. As many of you will know, concrete industry uses copious amounts of water. And it's not just in the actual building process, but actually it's in the curing process where they use far, far more. And if you take this into a rural area, it's a cost that is rarely founded or factored into a construction project. And primarily because the women are the ones that go to collect the water. The women go to the rivers, collect it, and bring it, and the cost is for them negligible. But actually, it is a huge cost. When you bring this into city areas, when you bring it into industrial areas, you suddenly find that water costs actually become factored in and become very, very important in it. One thing that just some technical issues. Questions might be raised about how strong it is. There's a lot of research has been done, and the dry density of rammed earth can be sort of compressed to 2 to 3 MPa. And if you add a tiny bit of cement as a binder, so we're talking about 5% volume, this can actually be increased up to 10 MPa. Now you might think, well, 2 MPa or 3 MPa doesn't sound an awful lot by itself without cement. But the typical downward force on a single structure, single story building would be approximately 0.1 MPa on the walls. So it's well within any safety margins without any cement added to it, or lime is another. Powdered lime is another binder which is used within it as well. So rammed earth really has a legacy as well of going back many thousands of years. And just to give you a little brief history on it, there are many, many examples of earth buildings right throughout the world. But what we do have very, very clearly is we have a temple in Japan. Horyuji Temple has got a rammed earth wall that surrounds it, which is over 1,300 years old. And it is standing, it is very strong. It's been well looked after and maintained, as any building and structure should be, but just goes to show the durability of it. And UNESCO has actually declared it a World Heritage Site. The oldest buildings will go back to 8,000 years old. Great Wall of China, part of it is rammed earth. And what we do know is in Spain, so we don't have to go very far. In Spain, there's evidence of structures which are still standing. Some parts of them are over 1,200 years old. But if we want to come closer in Germany, there is a building which is over 200 years, 234 years, 235 years old. It's 7 stories high. It is unconsolidated, which means it is just earth. So there's no cement or lime mixed into it. And it is used by the general public 5 days a week. So that's over 200 years old. In France, the longest building is actually used by the French government, and it is a round earth building, unconsolidated. And again, it's nearly 200 years old. We have many, many examples of it across Europe. So the evidence is there. And as I had said earlier, one of the main reasons for sort of moving away from it is because the way commercialism looks at cutting costs, commercialism looks at speeding processes. And so earth as a medium has kind of been put to the side. But there's, as I say, a renewal in the whole process because of environmental issues. And this is where round earth really sort of stands out in many, many respects. Early advances have been in mud blocks and adobe, with a lot of sort of evidence in the whole global popularity of it. And today, however, round earth is sort of being seen as with renewed interest for many good reasons. And while we see that cement is one of the major ingredients in concrete, it is also the second most consumed material on this planet. When you look at the cities, when you look at what's happening to cities and how there's a migration of people, cities are exploding. Big problems created because of the way cities are built. Water penetration in these areas cause flooding as a direct result of the way the planning is done, and also the way concrete is used. It's also massive, massive water consumption. Runoff is a massive problem as well. So all of these things are sort of good reasons for looking at trying to see if we can reuse earth as a medium. But also a manufacturing process. There's two processes. One is a wet manufacturing process and one is a dry process. The wet process is far, far cheaper. And so it is the one that's used because of economics. But one of the big issues with this is that the water that's dispelled contains solids such as sodium, potassium, chlorides, hydroxides, sulfates, and also some heavy metals, including lead. And you know, when that goes into the water system, the results of this. It was only in 2003 that, 2006 that America, or two or three states in America decided that they would stop the water process of manufacture. Now, what happened was that these companies that were in those states actually moved. Instead of changing, they actually just moved. One or two actually moved to outside of America with the concern that other states were going to go in the same way. So they ended up going to Africa. So the only reason why you do that is because the profit margin is so huge in doing that. But there is a better way, and that is the dry process. But it is a lot more costly. Maybe I just give a moment if there's any questions. I'll just say if there's any questions that come up which you think are actually relevant for that particular time, just give me a shout. Otherwise, just put them in, as Mike was saying, type them in.
I just wanted to check, Stephen, you're not expecting us to see slides, are you, at the moment?
No.
No, I was just checking because I didn't think so, but I just wanted to be 100% sure because I
have a couple which I will show in a minute.
Okay.
Just to go through a list here of things. Round earth walls are very sustainable. They have a natural low carbon footprint. And also it can be reused. If it's in a natural earth state, the walls can actually be removed, broken down, and actually can be reused again. So it's recyclable. They're good load bearing, quite conventional in the shape. And this is one of the big issues that if you go into a rural area, that you will find is that traditionally you have a certain style of the building, and many of the people who are in the villages are all aspiring to what the designs that you see in the cities. And so they would just automatically just think, well, I don't want an earth building, because they automatically think of a round mud hut. So round earth actually deals with that issue directly, because you can have really lovely designs. It's also non-toxic, has an excellent thermal mass, and it is great both in very, very hot climates, where inside the building it will be lovely and cool, but also in cold climates where it can be warmed up and it can hold and slowly dissipate that heat into the actual rooms itself. So there's a lot of benefits there. It's fireproof. It can be very, very attractive aesthetically. There's no need for plastering. There's no need for painting. So again, you can be minimizing the costs if the technique is done correctly from the start. It can be quite unique and quite individual. It can be cost effective as well. One of the biggest issues is labor. So there are ways of getting around labor costs. Collectively working together is one way. So you have 3 or 4 families working together, each helping to build, reducing the labor costs, which actually becomes one of the biggest costs within a sort of a labor intensive building. It can breathe, and it doesn't hold on to the moisture. Concrete buildings, when you'll find in certain cities where you have monsoons, the designs in the cities have not dealt with this properly. They will absorb the concrete, absorb water into the concrete. Monsoon continues on. It does not dry out properly. You'll end up with mold, mildew inside. You end up with health issues. Earth buildings don't have that problem, because they'll absorb water, but they also breathe and they allow it to dry out. So you rarely get these health issues within an earth building. Very decorative, and of course it's very, very natural. The walls are very workable, and it's possible to fix things to them as well. So I just want to maybe show you 1 or 2 things here that just to give you an example of it. Here is a block that I made earlier a couple days ago. It's very, very hard already. And this here, I will make one in a minute, and you will see the technique, and we'll look at the techniques in which it's done. There are ways of doing this and using this in brick presses as well. So you can just make ordinary earth blocks, CSB blocks. So that's another technique. And you don't have to use cement mortar between them. There are some really nice designs where you actually have interlocking design on them. And then all you end up doing is mixing water and make a real sloppy mix with your clay. You brush it down and you put this on and slide it up to the next one. Leave it, don't move it, it seals. So it's a very, very good simple system of interlocking. And so if you have reveals put into the ends, a little bit like Lego. And you'll see as well what I've done on the ends here. This allows for a system in which you are then constructing on top the next layer. So the next layer actually then buries itself into that, and it stops it from any sort of sliding and movement acrossways. So just maybe if anybody got soil together, and if you want to get anybody who's got a jar, the first thing I will do is we're going to do a soil test, and just to have a look at what your soil is like. Now, this here is a simple test that can be done in the field, and you can see by what we use, very, very simple things. We just need a jar with a lid, a little bit of salt, some soil sample that you have, and water. And it's called the Mason test, and it's been shown that it's very, very accurate. You can take the same sample, send it away to a lab, and you'll probably come back with very, very similar results as what you'll get here. So this again is just keeping it simple. In the field, you can do your test on site right there. So what you do first of all is you will take your soil. So a nice sample of the soil. I'm just going to use gloves here because you just fill as much, well, say about halfway or 3/4 of the way into the actual jar itself. And once you've done that, so you got something like that, okay? Then what you'll do is you will then fill as much water into there as possible. So it's just about up to the top. Give it a little movement round and the soil will have dropped down to the bottom. Then you would take, sorry, go ahead.
Sorry, can I just ask, are you using topsoil or subsoil?
This is subsoil.
Subsoil, okay.
Yeah, okay.
Thank you.
And I'll explain a little bit later the ideal for that and what the technique, what you need to do. But for this purpose, it was just a case of getting some soil, and it'll actually show you some of the things that you are to try to avoid and to eliminate and remove as well.
Okay, cool.
So then you will put in what I would say just roughly about a teaspoon of table salt. There we are. Put your lid onto that, nice and tight. And then what you've got to do is you've got to shake it thoroughly, thoroughly shake it, okay? And ideally you need to shake it for about 2 or 3 minutes, making sure that the water really gets into it and all the soil that's inside there kind of breaks down. And the idea behind that is that it helps to reveal all the different layers and different materials that are actually in your soil itself. And then what you do, once you've done that, and this is crucial, once you've done that, you then take it and place it in a place out of the reach of anybody, and nobody touches that for between 12 and 18 hours, okay? And what that does now, that salt will also help, particularly helps to cause the soil to settle. But by shaking it like this, what you will have, I mean, I haven't got time here, and this soil has sort of been cleaned quite a bit. You'll end up with different layers appearing. And what you're looking for is you'll have all the most dense particles will go to the bottom. So stones and sand will go towards the bottom. Then you'll have your silt. Then you'll have your clay. Then you'll have your water. And then on the very, very top, you'll have your biomatter as that will float. Now, what you can do in this is you're looking for ideally a percentage of clay, which will be between 15 and 30% of whatever your volume is of that's settled. That's the ideal, 15 to 30%. You need some sand in there. That will help to give you a bit of binding and some strength to it as well. Your biomatter, ideally you want it without any biomatter. The biomatter actually degrades and breaks down, and it will cause pockets inside and creates a weaker structure. Now you can easily measure this as well. If you were to mark this beforehand in certain increments, or simply just get a ruler, and so you can work out what your proportion is very, very simply. So that there is called the Mason test, soil test. Very, very simply done and very, very effective in providing what your soil samples, if your soil sample is suitable. So there we are. That's that. All of these things I have drawings for, and I have I can actually send them to people if they're particularly wanting them, etc. And there's also with many of the other things as well. Any questions on there? Nope. Okay. So if you look at when you've got your soil sample and you find that you have, let's say you only have a very, very low percentage of clay in it, one of the things that you will need to do is you need to be able to look at it and say, well, is there sufficient clay in there to work with? If there is, what you might need to do is to be able to add another form of a binding, which can be, as we said, cement, and normally between 5 and 7% volume is what's used. Or you can use lime, which is one which is preferred because it's more environmentally friendly, but it does depend on availability as well. And the lime is normally added is 7 to 10%, so it is not quite twice, but up to twice, close to twice the amount. That helps with your binding. What you can do is you can add some sand to it as well, if you haven't got the sand, if you haven't got the stones in it. So if it's a very, very fine area, but still has a clay. Now, if you have too much clay, you can add the sand into it, which then reduces your proportion. So the proportion of clay within the volume of it by adding sand. So there are ways in which you can actually play around with this. Okay.
Sorry, can I just ask a quick question? My field has got 50% clay in it. Mm-hmm. What proportion should I try and get?
You're looking between 18 and 30%.
Okay, so I've got a bit.
So in your situation, Eric, you would be looking to add sand into that of some form. Okay.
Okay. Thank you.
Yeah. So we've looked at sort of analyzing the soil. Now I want to have a look at some soil, play around with a little bit of soil just for a few minutes now, and looking at how else we do soil testing. So again, one of the quickest ways of looking to see if you've got any clay in your soil is to take a sample of it and squeeze it together and kind of smear it. It's called a smear test. Now, a clay sample will smear really nicely and it will leave you a shiny, glistening surface. So straight away, you'll be able to see if it's suitable. So that you do that before you would even do, maybe even doing this test here. Another thing as well, another one is called the cube test, where you get some soil and you work it together. Okay, you thoroughly work it, keep pressing it and sort of forcing it together. It's got to have a slight dampness to it. And you end up trying to produce a cube. You then put it down and let it sit and let it dry. It might take 3 or 4 days. It might take a week, depending on what your weather conditions are like. Now, what you'll find is if there's a high clay content in it, you will end up with some cracks that will form. This isn't, but I've deliberately done this because I did it. I made this earlier today and stuck it on the radiator. So it dried out very, very quickly, but it did exactly what I wanted it to do. And that was just to demonstrate this is what you will end up having. You'll have some cracks if you've got clay, quite, a good amount of clay in it. And what is good is that you have soil samples from different areas as well. And so you use these soil samples and you do all these tests just to see if you can get where is the better area to actually get it from. So that's one example. Now another one as well, which will show you how much clay you have, is called the roll test. So you again, you take some soil, and what you do is you press it all together, and then you start rolling it out. So you're trying to elongate it. And what happens is there should be a certain time when it comes to about, I think it's about 3 centimeters, 2.5, 3 centimeters, it should start breaking off. It should start breaking off. And when you find that it starts breaking around that point, there's a nice binding that's happening, but also there is that breaking which will happen when you've got clay in it. The clay will cause it to fracture off. So again, that's another test. They call it the roll test. So those are basically the 3 tests that you will be looking at, simply to do, and then doing your Mason test as well. Now, you should be at this stage, you should be able to know whether your soil is suitable or not. And ideally what you're looking at is when you're digging, you're looking at digging down 2 foot below, and then you're getting rid of most of your biomatter. You'll find subsoil earlier than that, but in many places, again, it depends on if you have heavy rains, quite often subsoil is actually being exposed. But going further down helps to remove the biomatter. Okay, I'm just want to add, I'm going to share a screen here and add a couple, show you a few things here if I can.
I just wonder, we've had one question before we move on. We've just had one question about from Mike on the chat. Without the salt, how long does the settling process take?
What the settling will happen the same. What the salt does, it helps to actually separate it better. And you'll notice a difference. If you don't use salt, you'll have a you'll have a lot more blurred lines between the layers. The salt helps to actually separate the different levels. That's why we use that.
I've got a question about you. You showed us your cube with those lovely cracks in it. Now, I kind of think, are you pleased about those cracks in there? You know, because
I am. And the reason for this, it shows me that there's clay. Well, this one here hasn't got a lot of clay. It has got a little bit, but if I do this naturally, if you put it in a shadowed area, sheltered, then you probably wouldn't get much cracking. But if you were then to put it into the sun area, into a warm, direct sunlight area, you will then find that there's cracking going on. So that is what you're trying to do. What it's trying to do is you're trying to demonstrate to see, have I got clay in there? That's what I'm looking for. Once you've established that, there are ways of doing this, building this without actually having the cracks.
Right. Okay. Yeah. That was because I was kind of thinking that seems to be indicative that your clay content is too high.
Yeah. It would be if all the other processes you were doing correctly and you ended up still having cracks in it. Yeah. That would be correct. Okay. But this here was to demonstrate what I'm looking for. Okay. Okay. I'm going to share a screen and let's see if we can do this. There we go. Okay. I think. Okay, just let you guys be able to see here. Here is the Mason jar test. So you can see very, very clearly the different layers that you've got there. And in this one, what we see here is you've got a lot of gravel in the bottom. You have a little bit of sand. Then you have predominantly, it is, what's that there? It's not really, you haven't got much clay in there at all, but it's predominantly loam, that lighter color. There's a bit of a sandy loam in that. So here, in this one here, there's very, very little clay. What I found is this test also is very useful in that I've worked with people who are building, and I say to them, go and do X number of soil tests, and they then take photographs of them and they send them to me on WhatsApp. And I can actually quite look at this and tell them, you know, roughly what their soil is actually like, and it helps. It's a particularly good way of helping them. Okay, we're going to move on. We're going to move on here, and this here is a ramming, or sort of the ramming technique and the shutter technique, and this one's quite important. So I want you to be able to look at this here, but then I'm also going to give a little bit of a demonstration on how it's done, just very, very quickly. So basically we have a shuttering system, which in simple terms works like a cake tin, for those if you've not used shuttering. And what it does is it encases and encloses whatever material you're putting inside it, and it gives you that rigidity. So when you start pounding down onto it, it stops it from spreading and disappearing. It wants to hold its shape. So you can see there, the yellow sides are the shutters, and it's a cross section. So what you will have is on the ends of it, you will have pieces of shuttering which stop it from moving forward. And I've just got an example here, which I've got here. If you can see here, so basically you've got the two sides and you have the ends, okay? And we put the soil inside here. And as you can see from that diagram there, what you do is you roughly put in 4 inches. Doesn't matter what size the building or what size your shutters are, the depth of it goes down about 4 inches. The ramming normally rams down 50%. So it goes down to half the size. So you're down to about 2 inches. And then you will put another 4 inches on top, and you will then ram it down. So the process, and that's how you get all these strata layers. This makes it easier to ram down. It gives you a uniform ramming system. So each layer becomes quite uniform. If you were to have it too high, you can imagine that your upper layer is going to be more compact than the lower layer. So the 4 inches is quite optimum, and you can over ram it as well. By having the 4 layers, the 4 inches, it means that you can have the stratas, which gives you quite a colorful, quite an attractive finish to the wall. You can introduce colorants into it, so you can change the colors, vary the colors very, very slightly. And also, if you look on the right-hand side, you don't necessarily have to have it exactly level. So again, you can create some beautiful shapes and beautiful designs if you want it as a feature wall. So just going to take a minute here just to show you. So we have the shutter system here like this, made up the 2 sides and the end pieces. We can also have them as a T-piece, so it can be a corner or a corner unit, or a T-piece where you've got an internal wall coming from the outside. It just depends on what part you have, but that's basically the 3 types of shutterings you have. You will then put in the soil into it. And then very, very simply ramming it down. And this can be done by using a pneumatic rammer. I tend to favor just an ordinary tamping, which you would get in the villages. Many villages would use it for groundwork, for earthwork. It's a local, you ask what the locals use and go and use what the locals use. It's far, far simpler. It also means that you don't have to teach them as much. They already know how to do that. So here it would be a system in which you're pounding down. You could just tamping it down by hand like this. I've just got this here just to make it simpler, and it keeps it nice and uniform. Technique's exactly the same. You're applying you just keep down until what you'll find is when you're doing it, you will hear the sound change. And as soon as you're getting a ring out of your tamping, you know that it's actually at the right compaction. And the only way to do this is by actually doing it or listening to it and hearing it actually happening. And once you've heard it, you won't forget it. You will know when that's happened. So you end up pounding that down as hard as you need to.
Watch your fingers.
So I will keep on doing so. I do another layer maybe on there. Let's just do that there. So much simpler when you have a little model than on the main one.
Yeah, if I can just break in, Stephen, I'm a bit confused. You've now said you're using a model. I mean, I envisage when you said rammed earth, I'm thinking about something about 4 feet high and a foot thick, which actually needs the two sides of the shuttering need to be held together. You're doing the whole demonstration with a model.
I am.
Is that right?
Because it's very difficult to get a full size shuttering inside the building here and to be able to do it. So, but I will show you a photograph or two. And I have them also on my my Facebook page, where you can actually see.
Oh, that would be helpful.
In
so in fact, we're talking about having to put in some kind of bracing and restraint to the shuttering.
Yeah, yes. And you will. I've got some designs there which you'll see shortly. Anyway, so what happens is once you've raised it up to that height, so when you're doing it on the building site, this height here will be approximately, I use 8x4 sheeting, plywood.
Yeah.
It's easy to get hold of. 2, it's easy to work with. 2 people can assemble a complete shuttering system. So it's, you know, it's just a very, very simple system. They can lock in together. And the way I've designed mine as well is that there's no tools apart from a hammer.
So you were going to, yes. I mean, I've got 4 sheets of the stuff at the moment, and I've got a whole series that I've put down for another purpose. So I'm used to handling 8x4 sheets.
Yeah.
But you were going to tell us how high you would create a layer before you actually rammed it.
Yep. So what I would do is imagine this here is about 8x4.
Yeah.
So what happens is you have a little bit of a what we call a little bit of a lintel in which you can clamp onto. So that's normally about 6 inches, which takes 6 inches out of the 4 feet.
Yeah.
So you're working basically 3'6" on each level. So you take the layers off, or the shutters off. You end up with your, imagine this being your 3'6". And then what you do is you then goes onto here, that goes onto there, and you mount it all onto here at that height. So again, it will be roughly about 6 inches below. And when you look at the shuttering, the drawings, you'll see how it's held together and how it actually rests on there. It's a very, very simple system, okay? And then you literally start ramming, filling the soil and ramming immediately on top of that. There's no waiting time required. One of the things that you will be looking at is you're looking at a moisture content of approximately 20%, which is generally what the moisture content will be in subsoil at about 3 to 6 feet deep. Very, very little water is added to it. One of the things that I did on a building site where I was doing some training was we actually calculated the amount of water that was required. And we ended up working out that if each person who came to the building site was to bring 5 liters of water, each person, there would be sufficient for drinking and sufficient for building. That's all that was required. When you look to see what is required when you're building with concrete, you count the tankards that come in with the water. There is a huge difference.
Can I just ask, your lintel, what's it made of?
The lintel will be, okay, the lintel can be made with two different things. One of them would be like a concrete, effectively like a concrete foundation. It'll be, so you have your foundation and then you build this lintel on top of the actual foundation itself. So if you can look at this here, look closely at this, If you imagine that this here is your foundation width, this is going to be the width of your wall, and this here is your lintel, this piece here. So the lintel is 6 inches above the foundation, and your shutter, it means that that gives you that first thing for your shutter to actually clamp onto.
Yeah.
And you're using concrete for all of that.
I would use concrete for that.
Is there any kind of substitute?
Right. Well, first of all, the foundation, I would my approach for the foundation is I always look to see what the locals are building with, rather than try to teach them, because partly I can get them to build the foundation before I come to do the work and to do any work training. That can save a lot of time.
Yeah.
So they can build the foundation. And then I would then build this on, unless I've got somebody whom I've already trained, who I can send there and get them to build this. And this needs to be very straight, because this will determine how straight your wall becomes. So I tend to use a concrete mix. If you want to put a little bit of rebar into it, you can. It's not necessary, but it can be done. Okay.
You mean horizontal rebar?
Sorry?
Horizontal rebar.
It can be horizontal.
Yeah.
Or if you want, you can also put little bits of vertical rebar in there, which help to lock it in. It can work both ways.
Have you used anything other than concrete?
Yes, you can use soil for your foundation.
Okay.
What you do need to do when you use soil, and that was a traditional method, you then need to put a drainage on this side, so a soak away drainage. And then on this side here, you will then need to have a damp proof course to protect your rising damp from the foundation bit up through into your wall.
Okay. Yeah, that's what I'm trying to get away from, using concrete.
Yeah, fair enough.
Okay.
Okay, let's move. Any questions on this ramming?
We've had a couple in the chat.
Yep.
One is, I think you said that, but I think just perhaps going back to it is from Roy. How do you assess optimum moisture content for compaction of the wall? I think you said the number, but without sort of putting something in an oven, how do you know when 20% is 20%?
Okay. I have this in my manual, and what you do is you can reach into your soil, you take a handful of it, okay, and you start squeezing it together, okay, and you create yourself a ball, and you keep working it until you get quite a nice round ball, which is holding its shape together. If it starts crumbling, it's too dry. If it goes together and it becomes very malleable, it's too wet, okay? But if you get to a point where you think, I've just about got it right here, you've got your ball, and so you're looking at trying to make something about the size of a golf ball. And then what they have is called a drop test. And this is where you stand up and you hold this ball at waist height and drop it onto a hard surface. And what you're looking for is for it to crack and produce 2 or 3 cracks in it, which you can then pull apart. If it drops and shatters, it's too dry. If it drops and goes, it's too wet. Great sound effects, yeah? But it works.
Sounds highly scientific to me.
Yeah.
Yep. And you know what? You can go, and I'll guarantee you can give me a soil sample. I will do those tests for you. You send the same soil sample away to a lab, and I will come back with roughly the same results. And after a while, you learn very, very easily. You can put your hand into a pile of soil, pull out, and quickly do that. And within a matter of minutes, I can turn around and say, right, that is actually 20%. That is about 15%, or that is 25%. It is actually that accurate.
You're a magician. Stephen, I think.
No, you know what? As you know yourselves, when you start doing something, after a while, you don't need to work it out. You don't need to think about it. It just, you can, you know, you learn, you hear it, you see it, you watch it, you feel it. You don't really think too much about it. You just trust your instincts after a while because you just know what you're looking for.
We've got a couple more questions. One of them's going back to the Mason test, saying it's difficult to see the difference between silt and clay with the naked eye. How can the difference be seen in the Mason test?
Well, you can see the difference. You can. There's because see what you do is that you do have those layers. You have the soil, you have the stone and the sand, you have the silt, and you have the clay.
Yeah.
You will have those. You will see them.
Okay.
You will see them. You won't see them now. If I bring this up, you might better see.
It's starting to develop, isn't it?
You can see it developing a little bit there. And you can see actually also just a little bit of the biomatter floating at the top there as well.
Yeah.
But here we've got I've filtered out, I've sieved out all the stone, so there's no stone in this. But there's a certain amount of clay, and there's it's quite a bit of silt, and there's a little bit of clay there.
Okay, thank you. One more question. You mentioned it's possible to over ram. What happens if you ram too much?
If you ram too much, what you have is a balling effect. And what then happens is that your layers can actually start to slide and they slip. So that is why you got to be very careful that you don't over ram it, because you actually stop it from binding. That's effectively what's happening. And then after time, your wall can actually slide. It can slowly slip.
Okay.
This photo here is an example of just the different colors that you can use in different layers, quite aesthetically.
Are you able, with the slides, are you able to set the PowerPoint, the slideshow going? If you see what I mean, I think because the actual, certainly on my screen, it's quite small.
Okay, on mine it's a full size.
What is it?
Yeah, well, we are looking at contact prints effectively on our screens. So even
Wow.
Well, all I've got at the moment is slide number 2, very small in the left-hand side and slightly bigger, but still not legible in the center of the screen.
Okay, what I have here is just one big slide in the middle of the.
How strange.
One big slide. I don't understand.
Can you can't change the
I can't, well, I've got a full screen with mine here.
Okay.
Let me just. So you're just seeing a very, very small thing.
We're just seeing not in the actual presentation mode.
But I think you've got enable editing on, needs to be clicked on, and then you need to click on slideshow.
Enable editing.
That's what it's shown on our screen at the top.
Yep.
Very odd.
That's is that from me or for you?
I think it's from you.
Because I have nothing showing on mine to do that. See, if I go to stop sharing, and then
It's probably one of the intricacies of Zoom.
is that any different?
Ah, that's better. Yep. Woo.
Much
Okay.
better.
Right. Can I then go back and?
Yeah, you should just be able to go to the bottom left-hand corner, and there should be a little arrow that comes up.
Yeah, I don't.
Yeah, that's it.
Ah, what a difference. Ah, yes.
Okay.
Was
Why
there, was there one
Why didn't
before?
someone say this earlier? There we are.
Ah,
Right.
Well, it's very difficult because we don't want to stop you in your flow, but also we weren't sure whether that's what you were intending to show us. So
Right. There we are.
Ah, I haven't seen that slide at all. So that's slide number 1. Right.
That's amazing.
so which is the silt and which is the clay?
This one here has got very, very This
The
one here,
little yellow stuff.
you can see the sand, there's sand and stone at the bottom there.
Yeah, yeah.
It looks like it's in two different layers, but it's not. It's one layer. One's got a shadow, a bit more of a shadow on it. And then what you have is you've got silt there. There's very, very little clay in that.
Yeah.
Very little clay.
Which
There's
is
no,
the clay
there's
that's
no
light-
biomatter. What's that?
The clay is the lighter coloured stuff, is it?
Well, I think that's silt.
Ah,
I
okay.
think that's in this one, I think there's silt. There's very little clay in this one,
So
I don't know how
the
you can
clay's
tell.
the, sort of-
which is
the
unfortunate.
clay's the layer in between the two. You know, sort of-
The clay is the layer just below the deep brown.
yeah.
And it's very, very thin. It's like the ice.
Very thin.
Okay. Right. Yeah. Yeah. Okay. Got it.
Very, very thin. Okay.
Right.
So here we are. Let's quickly go through this. So you can see that as I was explaining how it was being done, and you can have the different layers, and you can change the depths of the layers as well to give you a different effect. And this is what you can do. You can play around with it as well. Okay. Now, if we go on to here, this is a question that was raised, I think, by you, Eric, about the foundation. And you can see here what you have is conventional sort of footings there, which are actually earth. So if you have a drain on the outside of it, it helps to protect that. But then even though you get some moisture which will rise up inside that, if you have a DPC put in there, that prevents it then from going into the building and then going up the actual earth wall. So you can actually, you can use earth all the way.
Okay, so are we looking from left to right, from outside to inside?
Left is the outside where the optional drain is. So
Yeah.
the inside on the right hand side there is the floor slab, the inside. You can see the DPC comes from the top of the
Yeah.
earth foundation, drops down and then goes down above the actual soil underneath the insulation.
Okay.
Okay.
And what's the brick upstand?
That there would be what I was doing, what I was saying there about having that 6-inch lintel that you clamp to.
Okay, and is that still made of concrete, or can you still make that out of round earth?
I mean, it's hard to make it out of round earth because you do need that restriction that you have. So that's why it's being used. You'll find something more substantial to give you that clamping to. So,
but it reduces the amount of concrete by quite a lot, though, doesn't it? Because you just got that little layer that you're going to clamp onto, rather than the foot foundation underneath.
Correct.
Perfect.
Correct. The thing about also the conventional footings there, you can use stone and infill with soil. And if you soak it, so you dig your trench, fill it with your stones, and then infill it with soil and absolutely soak it. The soil just falls right on down through. You can then also pound on top of that. And that is another way of actually putting in your footings without using any concrete.
Would that be like loose rocks?
It would, yeah.
Because I've got a lot of loose rocks.
Okay, if we go up, once we've gone up the walls, this is another big question that's always attached. How do you attach the roof to the wall? So there's a number of ways. One of them is probably favored by an awful lot of people from a safety perspective, who are kind of adverse to risk, is that you pour a concrete ring beam. Okay, that's the simplest way. So you pour a concrete ring beam on top of the wall, shuttered in, and you will have maybe some ties that you will put into that. And when the concrete has set, then you've got the ties in which you can attach your timber joists to, which are attached to the wall. Okay. The other way of doing it is when you come to the top layer, the last bit of the shuttering, you will put into that ties in which are bedded in and rammed in. So they can be rebar or whatever, and they can be dropped down almost to the length. So the roughly about 3 foot inside that top shuttered part of the wall. Pokes out the other end, and you've got something which you can attach your timber to. But you will then have, you put a plate on it, and this can be just a timber plate all the way around. Your ties wrap around the timber plate, and you can attach, then you can attach your joist to that. Okay. Any questions?
So the ties are just embedded in the ramp, in that rammed section. Okay.
Yeah. Okay.
How do you hold your shuttering boards together?
Okay. This talk that I normally give is normally a 1 day's talk. There are, how can I quickly, okay. I would just quickly explain this and run through the questions if you have questions on it. So imagine this is your 8x4 lengths like this. What we use is we will drill normally on this 3.5 foot section. We will drill 3 holes, and the first hole will be about 6 inches up from the bottom. If you can see there, 6 inches up from the bottom. And we will have electrical conduit piping, 15 mil, okay? Which we place the width, which is the width of the wall, exactly the width of the wall.
Mm-hmm.
And we will feed through it a threaded bar through this hole, through the conduit, and out the other side. And this will have a very, very coarse thread, which you can just quickly turn by hand. That clamps, so you have one this side, and it clamps it together. That's 6 inches, and this is what I was explaining earlier. That 6 inches gives you that bit to drop down over the bottom of that wall. As we have here, it allows it then to sit on that wall. Does that?
Yeah.
Do you follow that? Is that clear?
Yeah.
And that gives you exactly, so that will, you'll have about 4 or 5 of those along there, the whole length of it, the 8 foot. And you clamp that in, it sits on that wall, the existing wall that you've done. But that's where it also sits on that first 6 inches on top of your foundation as well.
Give you your width.
Exactly. And it clamps there, it holds this from doing this as well.
Mm-hmm.
So again, it can be mounted very simply with minimal labor. Then once you've got those bottom ones, the bottom ones are fitted, that lifts this up, put it onto there, you can actually then mount the other ones in there. You can clamp that in. This, the conduit piping also allows, it forces it to keep it straight. So the bottom and the top, you won't have this when you're tightening it too tight at the top or tightening it too tight at the bottom. It'll keep it parallel. It's a very, very cheap, it's very cheap, and no tools. We used to use threaded bar, with nuts on it, but again, we were losing a spanner, losing a tool in the villages somewhere. So we end up having this very, very coarse thread, with a very coarse nut threaded on it, and you can spin it by hand.
But you sacrifice the conduit; it stays in the wall.
Well, there's 2 options. You can leave that conduit there if you want, and what the conduit does, it allows you to pull out that threaded bar without any damage to the threaded bar from the ramming and the pounding down.
Yeah.
But what you then can do is, in this wall, you will see, once you pull it out, you will have the conduit sitting there, and you'll see the conduit. You get another piece of conduit, put it up against it, and tap it. And you can slowly push out the conduit far enough so you can actually get your hand around it, and then slowly twist.
Right.
And once you twist it, remember it's clay content inside, it causes a smearing, and you can slide it out. You then get some of your mix. You start filling it in there, pushing it in, packing it, and then you start ramming it very, very gently, and you end up finishing it off with hardly any evidence of having a hole there.
Right. But you obviously want to take that conduit out fairly sharpish after you've struck the shuttering.
Yeah.
Otherwise, it's going to cement itself in.
What we normally do is we'll take that out, fill in those holes,
Yeah.
while the bottom one is still at the same moisture content as what's going into it.
Yeah.
And then you mount the next one on top.
Yeah.
Okay. Any questions? What are we for time? Probably
If
over.
you don't do all
We're
the way,
getting towards the end, I think, of time. Sorry. Just sorry, I interrupted. Was it Alan? But I just wanted to check. Have you sort of have you come towards the end, or is there more that you?
Yeah. So I've come towards the end, and I've got a photo. This is where good having another laptop. I can actually get a photo of the drawings that or some drawings that I've done about how the shuttering is linked together.
Can I just ask one last question?
Yeah.
You know, when you say you're using 8x4 ply sheets and they're ready available sort of like everywhere, is that the case? Like South Africa is great. You can get 8x4s. What about places like India and stuff like that?
Okay, I'm having a debate with some people on my my Facebook page about the size of shuttering and everything else. Some of them are saying they got to use 18 mil. Some of them are saying bigger, and what 12 millimeter shutter is plywood is what I use. And in India, what I found was I actually found some which has got a it's like a resin on one side.
Yeah, the bumpy stuff.
But this was very smooth.
Yeah.
And what's nice about that is the clay doesn't stick to it.
Yeah.
Okay, the clay doesn't stick to it.
Yeah. Because I've used 8x2 concrete shuttering,
Okay.
which is very, very smooth.
Okay.
And it's the same system. It's the same system. It's a stepping system.
Yeah. So you can imagine this here. This is very, very smooth here. So one thing that for anybody that's doing it is when you've got this, when you're taking the shutter off, what's very important to be able to maintain a really good finish on it is that you slacken the threads, the nuts, not too much, but just enough, just to create a tiniest little separation. And then what you do is you tap the top with a hammer.
Yeah.
It causes the shear force to happen, the very slightest. And what happens then is it comes off without pulling any of the wall with it.
Yeah.
That is important. Otherwise, you'll end up with little pockets.
Pit holes, yeah.
And then you're having to clean your surface an awful lot. But 6 millimeter is also light. 12 millimeters light to work with, cost effective as well, and with the braces.
And how many ply sheets are you using at any one time?
Okay, two for the side.
Nice, yeah.
And then you have two little end pieces,
Yes.
which will be the width of the wall.
And is that just the two, and you just move them along section by section?
Correct.
Okay.
Correct. If I can, big problem that I had was in a corner, joining it in a way which kept it tight. So I ended up having a nice straight corner of the building. How was I able to do that? So what I ended up doing was, if I can, getting the two pieces for the corner shutter, so you can see there, like this. I then had braces that came, that one brace, the braces would have come and just gone beyond the joint. And they would overlap, these two pieces would have just overlapped each other. There was a hole drilled. So I had one at the top, one in the middle, and one at the bottom. And if I got them all in line, I just then threw a 12 mil rebar right down the middle of it. That lined them all up, and it did two things. If the foundation wasn't exactly square, it still gave me a little bit of play, the tiniest bit of play that I needed to allow for any shift in the squareness on the foundation. But it still maintained it nice and tight, and it wasn't going to bulge, it wasn't going to move. And the other beauty about it was no tools required. All it was is a rebar that was dropped down, had a bend on the top. You just pulled it out when you finished with it. It released it very quickly. So if I was just to quickly show you here, you might be able to see
Yeah.
Oh, yeah.
there's the internal and the external part of that shutter. And if you look also, the 3 braces that come down the side, and you can also see in the middle, the conduit pipe and the threaded bar that goes through that locks it.
Can you send us the web address or the whatever it is you've got it on?
Yeah, I can do that.
Thanks.
One more thing for anybody who's building them, I have designs. I have actually good engineering designs for them, quite detailed. But just briefly, you can see here as well. This is quite important. We never really looked at this, but you'll see in here on the corner, this corner piece of wood that's in there, and this middle piece here, these are called VDBs, volume displacement boards. So it can create a cavity. You can also, you use the VDBs for creating a cavity where you want to put your sockets in the wall before, so you don't have to cut the wall afterwards. So the corner one allows you, you do this on corners. So when you come to maybe a window, that say a window is being put here or a door is being put here, or if this was the end wall, you would have that corner taken off so that you don't knock it and break it. It also aesthetically makes it look nicer as well. Now this middle piece gives you an interlock for the next, when you add the shuttering onto the end. So it creates this gap, this hole in which you're filling in, which is in this existing wall here. So it's interlocked this way and prevents this wall from moving backwards and forwards. They're actually become locked together.
Are they sort of key-shaped, they're sort of V-shaped?
Slightly
So
V-shaped, so they can release themselves. Correct.
So yeah, so you can just pull them out.
Yeah.
Yeah.
Okay, I think that's pretty well covered most of that. The one thing that I will just quickly show you is I just talked about the VDB there for when you're maybe got a window or a door. So just a quick picture here just to let you see how there's 2 ways of doing this. There's the wall being done with the gap in it. You can then put your window, you can slide your window. If you've already pre-made these, you can slide them in. So it's quite a quick process. You slide it in and then you can just fill it up with some soil and brace it in nice and tight. Okay, quite a simple way of doing that. What it does is it reduces the disturbance of the wall after it's been built and after it's hardened. Keeps it tidier.
Sorry, Steve, are you saying you put the window in while you're building the wall?
Yeah.
So do you have a lintel over the top?
Yeah. You then have a lintel over the top, and this can be timber. Or if you want, you can use concrete, or in India, quite common is using granite. They have granite posts. And so we would use those. And those you clamp onto that lintel and you build your wall on top.
Okay.
Yeah, we've used round earth ones with reed bars inside. Okay. So you just make a 2 foot wide by 3 foot long or 4 foot long, no longer than 6 foot, because even if after 6 foot it begins to bow in a bit. No, but you can't actually make them out of round earth and just add some extra bars in.
Okay. Maybe just one last thing just to touch on. When you're looking at roof design, because depending on your climate, but ideally you want an overhang. And what they talk about is a 1 in 3 overhang. So if your wall go up 3 foot on your wall, you go out 1 foot overhang. So if you have a 9-foot wall for your up to your ceiling, you then have a 3-foot overhang. There are two reasons for this. One of them, it stops the driving rain from monsoons, which drive against your wall. And the other thing about it is it also gives you your added shade, so it helps to protect your wall from excess heat as well. So that would just be the traditional way about it. There's a lot of sort of technical stuff involved in it, but it's not something that we need to really look at. Maybe I'll give you one photo there just to give you an example of it, and that's sort of, as you can see. Okay.
So, Steve, you shared a picture earlier on. I think it was your slide 2, showing the different stratas there. But that looked to be longer than 8 foot long.
On the wall, the photo.
Yeah, on the slide.
Yeah. Oh, I know the one. Yeah, that photo is not something that I have done. That was as an example, and you will find that was probably done commercially, and they may have probably used big steel shutters, so they could have been a lot wider. I'm just wondering if I could maybe just have a quick look again. You're referring to this one here?
Yeah.
Yeah. So I was just thinking, if you're only doing it in 8 feet sections, then the grain wouldn't line up in the same way, you know, with the colors.
It might have been made by the same way they did the one at the Eden Centre, and that was commercially built using concrete shuttering.
Yeah. I can't seem to get it back up again. Actually, if you do look at that, you can see that it is actually, there's
they're 8 foot sections, aren't they?
there's breaks, there are breaks all along there.
Yeah.
Yeah. Yeah, I think the Eden wall's about 150 odd foot long.
Yeah.
So.
Now, if you just Google them, and you'll see some absolutely beautiful, beautiful things. So, okay. I think
I'm just a little bit conscious of time, that we said it would be finished by 9 o'clock, but it's been absolutely fascinating. I think one question I was going to ask, you mentioned a manual. Is that something that is publicly available? Is it something we can signpost to? Is it something we have to buy, or, you know, can we, because our plan is to publish this on our YouTube, and ideally from our website, can we refer to that or link to your site or something?
What I've been trying to do, there's a few things. My shutters, people have been using them, have been saying, Steve, you need to patent those because they are so good. And there's an engineer down in Australia who's a building engineer who actually works in rammed earth commercially. And he looked at that, and he wants the design. He said that is just so good. And I've given it free of charge for people. And I think that's, you know, ultimately that's the best way.
Right.
People can use it because it's simple. It is.
So what we would say is, I think what I would propose is that we'll publish this online, and say if anyone wants to get in touch, they join the you know, the Rammed Earth group, and we can signpost to that, and then they can get in touch with you, rather than just publish it online, and you never really know who's going to take it and use it for whatever purposes.
But it's, and also, yeah, I was going to say, you know, that Rammed Earth group, it was set up in order to, for me to be able to share the knowledge that I've got, but also to be able to bring people together, to network. And we've just clocked over 5,000 people there on that group now.
Fantastic.
It is, and they're from all over the world. And what's happening is that people are running workshops in different places around the world, which is great. And the thing about the nice thing about it as well, you end up with some good technical discussions going on, because there are people there who have been doing it for years, There are newbies, but you know what? There's the new people have also got some insights in their own areas, which, you know, experienced people. I'm learning all the time. I go to an area and I listen to what's going on there, and I think, oh, I never thought about that. Oh yes, of course, I can apply that there. And I think that is where this page has become so useful. So
Yeah.
Sorry,
So
is it
a Facebook group, is it?
it's Facebook. It's a private Facebook page, but
no, can anybody join, or
anybody
Yeah.
can.
So-
I just have to let you in. That's it.
can you tell us
do we
what
have
the
to type
Facebook
in?
address is?
I'll, I'll send it round with a link afterwards.
Michael,
Brilliant, thank you.
Yeah. Eric, presumably you got your information from Jeremy. We'll just ask Jeremy to send it
Brilliant.
after that.
Thank
Yeah.
you.
And I think if anyone else has got a really one burning urgent question, then let's ask it. Otherwise, I think we'll release Stephen and release everyone else. Has anyone got a burning question?
I've got one if no one else has.
Is it a burning question?
It's burning, it's really burning because it's, you mentioned at the start about it being good in earthquake resistance.
Yeah.
And I'm thinking of places like Nepal,
Yeah.
and the large earthquakes in the Kathmandu Valley in 2015. Has much sort of research work been done on this, or is it just from seeing them stand up in earthquakes?
No. Huge amount of research. And most of the research has been done in the States at a couple seismic centers. There's also another one in Mexico. They have been doing a lot of research in it as well. And the results that come out have been, you know, without question. It's not something which people are just sort of guessing at. It's proven technology.
Yeah, they built a whole one in Germany on a platform and then shook it to pieces, basically, to try and destroy it, and it just wouldn't break.
What they've done in the States as well, in them, they've built the concrete wall, non-reinforced. They built reinforced concrete wall. They've actually used rammed earth, unreinforced. They've actually then used reinforced rammed earth. They've done a whole lot, and they've actually just shaken the whole lot of it, and they've just looked right next to each other, all the different results of what's actually happening.
Yeah.
And just going back to Nepal, there's actually quite a bit of work going on with this, both using bagged earth, which briefly is just a technique in which you fill bags and you use the bags as building blocks. What I love about bagged earth is that you can use any shape and form. So you can have nice curves in your wall. Then you plaster it. Normally use a lime plaster. And it's just a lot more organic rather than the rigid sort of architectural shapes that you'll get with rammed earth. So they're the two. And also with they're using presses. So you're getting CSB blocks, which are being used now in Nepal an awful lot. So.
In 2021, the winter of next winter, Stephen, then you can talk to us about bagged earth construction if we're still around then. But I want to say a huge thank you to you, Stephen, for that.
Thank you.
I had to go out and wash my hands twice. I don't know about anyone else after messing around with earth, and I never really got a good.
I could have said go to get some gloves.
Thanks very much.
It's fun.
I had some disastrous results really with my earth. But just thank you on behalf of CED. It's been really informative and we really appreciate the time that you've taken. Just a reminder, we've got 3 more tech talks coming up. Jono, who asked the last question, is going to be talking about hydroelectric power. After that, we have Philip Tibendarana from Uganda, who's bringing a Ugandan perspective on development. And lastly, we have engineering in disasters from Jonathan Appleby, our chair, rather than disasters in engineering, which was my forte. But thank you very much, Stephen, and we'll close it there. I'll stop recording.